where in the pipeline, in the data pipeline or the machine learning pipeline, are data profiling and quality checks necessary?
I think one of the things I learned at Google is that simple analysis on top of high quality data usually wins the day. And that is sort of the ethos that I've tried to bring with me everywhere I went, from Cloudera to Slack to whatever. I've always been militant about we need to have schemas, we need to have quality tests everywhere. We need to know as soon as possible if there's a data quality issue, not in 15 minutes, not tomorrow. We need to know right now. And contextual bandits give us the opportunity to make those very sort of fast adaptive pivots to new data when we see it that is, again, harder in A/B testing, where it's I gotta wait a while.
Josh Wills, welcome to the Super Data Science Podcast. It's awesome to have you here. Where in the world are you calling in from?
Hey, John, how you doing? Thanks so much for having me. I am calling from San Francisco, California.
Nice. And actually, on the YouTube version, it looks like we can see that you have a sunny day there, perhaps?
We do actually have a sunny day here, which you do not always get. I live in the western side of San Francisco, and so it's not always sunny on this part over here, but we're having a little sort of window of beautiful weather before another atmospheric river comes in a few days and slams us again. So I'm enjoying it while we can. Yeah.
I haven't heard of these atmospheric rivers, but I guess that's it's just why it's always cold in San Francisco all the time.
Oh no, it's these really great, fun weather storm things. They call them. It's called the Pineapple Express, and it's essentially a river in the sky.
I thought that was a strain of weed.
Yeah, I mean it's that too. It's also San Francisco, but you can get a contact high just from walking around outside for an extended period of time. But no, yeah, sorry. This is I'm a nerd for weather stuff as well. I have I think you find this episode. I have a bunch of nerdy interests and stuff, and so Daniel Swain and Weather West, Weather Twitter. I love this stuff. We obsess about the weather out here in California. Even by American standards, we talk about the weather a lot.
Well, but I interrupted you. What is a Pineapple Express other than being
Pineapple Express? So there's typically a giant high pressure system off the coast of California that protects us from moisture, which is why it's always so sunny and nice here. But occasionally these low pressure systems manage to kind of pierce the high pressure system, and when they do, literally just an absolute torrent of rain and snow and other kind of weather comes, again, typically originating from Hawaii, and just slams right into us. And this has been happening here for the last couple of months or so. It's been, after years and years and years of drought out here, it's been just extraordinarily rainy, it's off the charts, quantities of snow up in the Sierras and stuff like that right now.
Right. So, yeah. Friends in the area have had they've had to have emergency crews to deal with all the trees that have fallen.
Exactly. Snow everywhere. And and again, and this is just not something we deal with well out here in California, at all. We're not equipped for this kind of stuff. And so anyway, yeah, this is, like I said, it's a big deal for us.
Well, so we know each other, not through any kind of weather affiliation, but through Eric Bernhardsen.
Yes, absolutely.
A really brilliant data scientist, software engineer, entrepreneur.
Yes.
And he was in episode number 619 of this show, which I recently did the tallying. It was the 6th most popular episode of 2022.
Not bad. Not bad.
Which is, unsurprising given how interesting he is. And I asked him, I said at the end, after we'd finished recording, I was like, Eric, you're one of the most interesting people in data science and software engineering. Do you have anyone else that you could recommend for the show? And he said, Josh Wills.
Oh man, that's I am honored. That is high praise coming from Eric. Yeah, he is Eric is who I want to be when I grow up. So that's deeply flattering. Yeah.
And then more recently, we had a guest on the show, Chip Huyen. She was in episode number 661.
Yes.
And she knew that you were coming up on the show in a couple of weeks. So she left a message for you.
I think I literally have an autographed copy of her book right next to me. That's kind of fantastic.
And we're going to talk about that later in the show.
Okay.
But so our very first question on the program is from Chip. She says, how did Josh become so interesting? He has viral quotes on Twitter all the time. How does he do it?
How did I become so interesting? That's a tough one.
We're gonna dig into it a bit, I guess.
Do I have to answer now, or I can think about it for a bit? I don't have to.
You can think about it for a bit, and we're also, the audience is gonna kind of get a sense of that, because we're gonna go through in kind of reverse chronological order, the extremely interesting things you're doing today, and then go back. It is mind blowing. Our researcher Serge had a field day trying to compress all of the interesting things you've done
Okay. All right. All
into
right.
the questions here.
Into the window. Sure. That makes
So,
sense. Okay.
first
Okay.
interesting item on Josh
Yes.
Rolls, what you're doing right now. You're an instructor for a brand new comprehensive course called Data Engineering for Machine Learning.
Yes. That's right.
And so this course is all about architecting the data infrastructure required to support scalable machine learning in production environments. Josh, tell us a bit
Yeah.
about the course.
Yeah, absolutely. So the course, which I teach with an organization called Sphere that teaches any number of classes on sort of all sorts of interesting
Chip
technical
actually,
topics and stuff.
she has a Sphere course
She
right now
does.
coming out as well.
She teaches a course based on, again, her excellent book, Designing Machine Learning Systems.
Mhm.
I don't have a book on my topic, but I am trying to distill my experience building data infrastructure at Google, at Cloudera for other companies, and then ultimately at Slack into like sort of 4 sessions, 2 hours a piece, where we kind of go through like this is how all of your data ingestion stuff like what should you do from a data engineering perspective when you're doing machine learning as opposed to when you're just doing like BI and reporting and stuff like that? Like where do you need to step up your game? Like I generally think of like machine learning as like software engineering on hard mode in every way. Like debugging is harder, monitoring is harder, everything is harder than it is under reg because just it's I describe it as like especially with like all the chat GPT stuff and going on right now. It's like deliberately injecting randomness and like spaghetti code effectively like these gigantic vectors into your production systems like intentionally like on purpose, right? And so how do you engineer around that? How do you defend against all the things that can go wrong when that happens and so on and so forth? And so that's basically what I try to teach. It's hard. There's like a lot to cover and we only have like 8 hours to do it. So we start with like just the absolute basic foundations around like data ingestion, like how do we schematize things? How do we evolve schemas over time? How do we be very, very rigorous about like I think the terminology. I joked the other day. We before ChatGPT, we used to talk a lot about data contracts in the kind of data Twitter sphere. But like that's kind of that idea. How do we essentially guarantee that changes in production don't break the machine learning pipelines that we use to power other parts of production? That kind of stuff. A lot about feature engineering, feature stores, like how do you do this sort of these calculations you have to do scalably? How do you do them fast enough? Again, this is something Chip knows a lot more about than I do, but I do devote a section of the class to it. Data quality monitoring again becomes like not just a nice to have, it becomes like absolutely essential when like the data is feeding again production machine learning systems. And then finally for me like the most fun stuff, which is I always think of as like the highest best form of data science, is around like experimentation, A/B testing things, and then kind of beyond that, contextual bandits. Like, like this is one of the areas I'm passionate about. Like, a lot of folks just build a like one-off machine learning model in a notebook and just be like, yeah, look at this cool model I built. How great is this, right? But like when you're doing this for real, like for money, you never stop building. You're constantly iterating on the model. You're constantly trying to improve it. If you're not going to do that, like why are you doing it in the first place? It's not worth it, right? And so exploring techniques for like how do we get better faster with less data is the final sort of like focus of the class and stuff. So yeah, these are it kills me, these are all things that I could devote months of discussion and topic to and stuff. I have to cover it in a relatively short period of time. So I'm working with Sphere to like kind of break out the course into like focused sections basically. Like each of these sort of like each of the individual sessions could be a course in and of itself, and I'm frustrated that there's like so much to say and so much to cover and not enough time to do it. So anyway, yeah.
Let's specifically dig into that contextual bandits bit.
Okay.
I think a lot of people know what A/B testing is. Maybe we can use that to like ease in. What is
Yeah.
like, for me, A/B testing is like really obvious when you're thinking about it in the context of, should we show a user interface that's blue or green?
Yes.
And which one's going to get people to click on more ads or buy our product or whatever?
Exactly. That's right. Yep.
But yeah, what's that like in the context of machine learning? That kind of A/B testing.
A/B testing multivariate testing is the gold standard for establishing, like whether something is sort of meaningfully better than something else or a meaningful improvement in some sense. There are, however, sort of a cost that goes along with A/B testing. The cost is that it takes a long time. It takes a long time to gather enough data to achieve the statistical significance that you're looking for. And there are a lot of problems where taking that time and making that investment is worthwhile and is definitely something you should do. There's a lot of things that are like, big deal decisions, right? That are not reversible. For instance, like, credit check stuff. Are you approving someone for a loan? Like these are big deal things. These are heavyweight. And so improving the systems via A/B testing is the way to go. There's a lot of other problems though, where like the A/B testing approach is kind of overkill. And the kind of classic one I think is like content recommendations, recommending news articles for people to read, recommending episodes of your podcast to listen to. No individual decision is like life or death, right? Like it's not the end of the world if someone gets like one bad recommendation out of 10 or something like that. Like the Netflix movie page is kind of in the same sort of boat, right? And so if you're in that regime, if you're in a world where like it's not a life or death decision, it's not all or nothing, you can use some techniques, including basically intentionally randomly injecting results, randomly injecting, answers in order to much more rapidly sort of develop an understanding and improvement and figuring out like the policies and the algorithms that will do a better job of recommending in a way that you can't in kind of other circumstances and stuff like that. So again, like identifying when A/B testing is the right thing to do and identifying when contextual bandits can, like, I mean, and not just like a little faster, like, an order of magnitude or two, like 10 times faster, 10 times less data is what we're talking about here with contextual bandits. And so, yeah. And again, it's one of those things that, like, it's interesting to me, like contextual bandits are like everywhere at Google and Facebook and stuff, and not generally out in sort of society at large. I don't think, like, we don't see nearly as many of them as I would expect, given how useful they are, I think. And this is just, again, something I kind of want to cover in the class is like, hey, this is really, really cool, very, very useful stuff that is worth having like in your toolkit for tackling data science problems. Yeah.
Nice. So to try to summarize that back for you, and I'm probably going to butcher this, but contextual bandit is kind of like A/B testing, but instead of having it be this like, oh, we're going to give 50% of users A and 50% of users B, instead you have a circumstance where, like showing people Netflix films, it isn't a matter of life or death, whether they, it's not like predicting a tumor in terms of accuracy importance. So you can insert in some random movies, some random outputs, and that data point provides you an order of magnitude more quickly in aggregate with how to be optimizing your platform or your machine learning decisions.
Yeah, exactly. You can sort of go back and play back the data points and evaluate algorithms based on how well they would have matched the optimal choices. The sort of standard way to do this would be to have like a current best model that is doing it, and 90% of the time, the current best model is allowed to make the recommendation. But then like 10% of the time, we essentially randomly choose some items to recommend, and then we evaluate like what feedback do we get? Like, did the person select the best one, or did they select like the randomly selected one? And if they selected the randomly selected one, well, that's really interesting. That tells us there's something about the quote best model that needs to be improved. And so we can be continuously training on this data. And again, for like news articles is kind of a great example. News articles change all the time. Like the zeitgeist changes all the time. Like when ChatGPT happens, we want to like immediately pivot all of our recommended news articles to be about ChatGPT. And contextual bandits give us the opportunity to make those very sort of fast adaptive pivots to new data when we see it. That is, again, harder in A/B testing, where it's like, I got to wait a while, I got to see, make sure the data is correct and stuff. And so again, when the stakes are lower, making the decision faster has a tremendous amount of benefit. Anyway, yeah.
Are you moving from batch to real-time? Pathway makes real-time machine learning and data processing simple. Run your pipeline in Python or SQL in the same manner as you would for batch processing. With Pathway, it will work as is in streaming mode. Pathway will handle all of the data updates for you automatically. The free and source-available solution based on a powerful Rust engine ensures consistency at all times. Pathway makes it simple to enrich your data, create and process machine learning features, and draw conclusions quickly. All developers can access the enterprise-proven technology for free at pathway.com. Check it out. Nice. Thanks for filling us in on contextual bandits. Sounds like they are super powerful, and people should be checking out your course to learn about them if they aren't already aware, given how widely useful they could be in machine learning applications. Another really powerful topic in your course is on data quality and monitoring. You've talked about
Yeah.
these topics a lot. We'll link to a few blog posts and talks that you have on it in the show notes. So,
Yep.
yeah, data quality and monitoring. Where in the pipeline, in the data pipeline or the machine learning pipeline, are data profiling and quality checks necessary?
Oh, and it's like, I mean, I think everywhere is kind of a, like terrible answer. I think, um, I think if you kind of look at the journey of my career, John, like I started out as just effectively like a data analyst kind of person and have sort of slowly worked my way down the software stack. And so like eventually I think I'll become like a chip designer or something, or like I'll be like fabbing silicon at the rate I'm going. But for
You'll
me,
be
yeah,
shaping kernels of sand.
I say actually that I mean that actually sounds kind of peaceful, dude. Now that you mention it, like actually sounds kind of nice. But the sort of the data quality and monitoring stuff was kind of like my main sort of leap from like offline data pipelines, sort of model training stuff to online like model serving, inference kind of stuff in a lot of like in the work I do, right? And so I had to learn about how do regular software engineers who are not doing machine learning, how do they monitor and do observability and stuff like that on their software systems? Because I suddenly needed this stuff that I needed to start understanding how this stuff worked, and so I could take advantage of the stuff that Slack had in order to be able to detect data quality problems, like yeah, essentially in real time, in real time. And this is something. There's a lot of ML ops, lots of data quality monitoring systems and stuff like that, and really like reaching a point where like I'm carrying a pager and I'm alerted when like a bad observation or like a search query comes in that like destroys the search index or destroys the query backend. These are all things that happen. Um, was a big, like inflection point for me in my career where I sort of, like I guess I've progressively become less and less of a data scientist and more of a software engineer. And that was a pretty big step in that direction. So yeah, I mean, I am like, I think one of the things I learned at Google is that simple analysis on top of high quality data, like usually wins the day, like usually wins the day. Um, and it's a lot easier to have like it turned out to be like at least at Google like a lot easier to have really really high quality data and do simple things with it as opposed to having kind of meh data or like a little bit of good data and then a bunch of maybe garbage data and then doing some fancy stuff to make it to sort of improve it or try to do it right whatever. And that is sort of the ethos that I've tried to bring with me everywhere I went, from like Cloudera to Slack to whatever. I've always been militant about like we need to have schemas, we need to have quality tests everywhere. We need to know as soon as possible if there's a data quality issue, like not in 15 minutes, not tomorrow. We need to know right now. Like that's kind of been my ethos for that reason. Um, and so yeah, like learning how to sort of the observability stack worked from Prometheus to Elasticsearch to Grafana to tracing tools like Jaeger and Honeycomb and stuff was just a huge like leap forward for me. Um, I guess like there's a lot of ML ops solutions out there, and there's like some really really good ones. There's some really cool stuff. For me though, like catastrophic machine learning failures are typically data quality problems and like very sort of in some ways kind of prosaic, boring data quality problems. A field that should be there isn't there. A value is taking on a value, like a field is taking a feature is taking on a value it's never taken on before. Like stuff like stuff that's not like rocket science that you can to check for, as opposed to things that are more subtle, like model drift. Model drift is a real problem, um, but like you can often just get around it in a lot of cases by retraining your models all the time, or using contextual bandits, for instance, retraining them in real time. And so yeah, that's sort of like why I harp on this stuff. I don't know. I feel like I'm always like my son plays basketball now, and a lot of it is like, how do you convince them of the fundamentals? Like, dribbling, passing, shooting technique stuff. Like, how do you make the fundamentals interesting? And that's kind of the same challenge I have in talking about this stuff is like, how do I make this very, very boring, low level fundamental stuff interesting and engaging to people? And that's kind of been like the arc of my career is trying to figure out how do I do that? because it's just stupid important, and it's important, but it's also just kind of boring and unfun. So like that's the trick here anyway.
Yeah, that I can commiserate with that because my first foray into content creation was deep learning stuff.
Okay.
And then once I had finished like a couple dozen hours of video courses on deep learning and I'd written a book on it, I was like, man, you know what my students really need to know more of, and I really need to know more of, is linear algebra, calculus, probability theory.
Totally.
And so
100%.
then that's what I've been teaching lately. And
that's awesome. That is fantastic. Again, not sexy, not whatever, but man, is it everything builds on top of that. And I don't know, but I guess I found this especially at Google. And I guess I want to tie this into Chat GPT if you don't mind, because I mean, like the problem is we've not talked about Chat GPT enough, right?
Yeah.
But like at Google, again, like way back in the day, like 2000, 2008, when I started there, you'd interview people for like statistician jobs. Like it was sort of like we didn't have the title data scientist yet. Like Jeff and DJ hadn't come along, so we're trying to interview people. And we would always interview around the fundamentals of probability and statistics and stuff like that, like to see who had like a really deep grasp of it. Because again, at the time, like when you got to Google, the problems were kind of like all flipped around. Like in sort of academic statistics and in much of statistics, it's like I have a small data set and I'm trying to extract whatever signal I can from this very small data set. Whereas our problems were the exact opposite. We are drowning in data. We have more data than we know what to do with. And our job is not to be confused by it. And so to do that, we kind of had to you just approach things from a completely different perspective. And that again builds on the fundamentals of probability, statistics, linear algebra, right? And I kind of feel that way about like the Chat GPT or the large language model world we're entering, where like for a long time, like if the computer gave you an answer, it was the right answer. like basically, right? It would either error or give you like the answer that you asked for. And now we're entering a world where like that's no longer true. The computer will always give you an answer, but it may or may not be true. And so like our whole mental model of like how we interact with computers is about to change in the same way that it had to, like working with very large data sets back in the day. Yeah.
And makes the testing problems that you were talking about even harder.
Exactly. Right. Precisely. Like all this great Bing Sydney kind of stuff. Like, oh my God, like how do we even begin to think about this stuff and test for it? And so this is the great challenge for me in my data engineering class, is like, how do I adapt for this new world that we're entering? Like, how do I like start preparing people for like how to work when like, the stakes are going to become that much higher and the systems are going to become that much more complicated. Yeah. Good fun though. Good problem to have.
Yeah. Recently in episode number 655, Keith McCormick and I discussed that all data scientists should consider no-code options because you might find that they enable you to prototype more rapidly. Keith has enjoyed good fortune with the no-code tool KNIME, spelled Knime, and more than 15,000 people have taken his Intro to Machine Learning with KNIME LinkedIn Learning course. KNIME is open source, so it's free to try, and with the link that Keith is providing to Super Data Science listeners, his KNIME course is free too. All you have to do is follow Keith McCormick on LinkedIn and follow the special hashtag SDSKeith. The link gives you temporary course access, but with plenty of time to finish it. KNIME can save you time, so check out the hashtag SDSKeith on LinkedIn to get started right away. Another big problem that you've talked about a lot related to data quality is integrating diverse perspectives in an organization when you're making, it's supposed to be a data-driven organization. So you've got people like data scientists, data engineers, you've got relatively quantitative business people, and yet these different groups disagree on what quality metrics to test for and monitor. So how do you deal with that? And is it part of what you've called in a number of talks, the infinite loop of sadness?
The infinite loop of sadness. Yes. Is it a part of the infinite loop of sadness? Yes, it is. It is very much to an extent. I think the idea of, I guess for folks who've not heard of the infinite loop of sadness, is that the stakeholders that kind of revolve around the data of a company generally report up through different parts of the org. So you might have business users reporting up through finance, like sort of G&A kind of stuff, some through engineering, some through product, some through customer success, whatever. There's all these different stakeholders for data. There's a data science team somewhere that wants to do sort of cool data science stuff, wants to get to like A/B testing, experimentation, contextual bandits, machine learning problems. There's a data engineering team, which may or may not be part of the same organization. Like could be like at Slack, for instance, like analytics reported up through product at first and then reported up through G&A, but data engineering always reported up through engineering. And so they're worried about performance. They're worried about cost. They're worried, like, especially these days, like cloud savings, all that kind of stuff. And then like you have the rest of engineering, which is like, trying to like terraform things and monitor things and observe things and keep the basic product up and running and stuff like that. And then they're like, oh yeah, there's this data warehouse thing on the side that we also kind of need to like provision some resources for and, terraform or whatever. Right. And yet, like, yeah, like the artifact of having, or the result of having all these different stakeholders in these different organizations with different objectives, with different goals is kind of this mess that leads from like business people hiring data scientists say we need data engineers say we need machines. The rest of engineering says, okay, finance, we need a bunch more money to pay for all these machines. Business is confused because they've hired all these people and spent all this money and don't have any answers to their questions yet and stuff. And so these things kind of spiral out of control. I don't have a great answer to this, unfortunately. I'd like to say that I do. Like it's something to identify a problem. I guess where I've seen it work well, or the best places I've seen it work, is where data is centralized in a single organization under a single leader who has like the trust and confidence of the rest of the executive team. This doesn't always happen. In fact, it hardly ever happens. And even when it does happen, it's kind of an unstable situation because once that leader leaves, it tends to be the case the whole thing kind of falls apart.
And it sounds like somebody like that would be a prime poaching target because there's.
Oh, I mean, 100%. 100%. I mean, it was sort of the joke to me, I think, was that when I was director of data engineering at Slack, I was essentially being continually recruited to be the head of data at Lyft, the head of data at Discord, the head of data at Snowflake, like more or less continuously. And I kind of thought like we should all like get together, like all of us, various heads of data who are constantly being recruited, and like we could just like collaborate more or less. We could just like set out our terms and say, like, okay, you go here and do this, and then I'll go here and do this, and we could just constantly keep switching between, like the orgs until we fixed everything. This was my fantasy. I never actually did this, but yeah. I mean, but yeah, you're exactly right. If you are talented enough and skilled enough to do that job, and it's like no joke, really hard to wrangle all those different perspectives and get everyone sort of rowing in the same direction. It's not like a skill I possess, for instance. But yeah, for the folks who can, they're tremendously valuable, and I don't think it's a coincidence that you've seen all those people go on to be tremendously successful founders, investors, all those kinds of things. Yeah, absolutely. Because it's super hard without a doubt.
Yeah, and we're going to get into this later in the episode. What it's like managing these teams at these fast-growing companies. We've got some stuff. We've got topics on that coming up. For now, I'd like to switch gears to note how not only are you renowned within organizations for the leadership, thought leadership, or literal management that you've done in the past in these really well-known organizations, you're also very well known publicly. So you are Twitter famous for defining what a data scientist is in this very comical tweet that I cite all of the time to define myself. Which is that a data scientist is a person who is better at statistics than software engineers and better at software engineering than statisticians.
Yeah, exactly. Yeah.
So this was written over 10 years ago. Do you think it's still true?
I do. I do think it's still true. It's funny. I think I hang out a lot with the analytics engineering community now these days, like the folks around DBT and stuff like that. And so there's a wonderful woman in that community named Emily Sharia who just started her own company called Turbine. She gave a talk last year called Down with Data Science. And she was a sort of engineering manager, data leader at GitLab and then at Netlify. And she does not like the data scientist naming or title thing. Because she feels that it's the term has become so overloaded as to become kind of meaningless, right? Like telling someone you're a data scientist doesn't really seem to tell you anything about like what exactly does this person do, right? And I think that's a fair critique. I think that's a legitimate thing. I think there are like I do think the data scientist title, while very useful and especially useful, like not for nothing at these like fast growing kind of tech companies I tend to work at, where you do need a lot of generalists, you need people who can wear a lot of hats and stuff like that. It definitely does tend to break down. And I think I'd like to think that over time, data scientists kind of like go into like one of three different directions. And so can you humor me? Can I haven't done this before. I haven't like pitched this, but let's see how
Not
this
only
goes.
will I humor you, I'm going to take
Yeah.
detailed notes.
Detailed notes. Okay. So I think one direction data science can go in is kind of the direction of like going really deep into kind of methodology and stuff like that. And so this is stuff like the folks who do causal inference, contextual bandits, like very advanced A/B testing kind of stuff. The folks who go to Google, Facebook, the Ubers, the Lyfts of the world, like where they have these really, really like legit hard statistical problems and stuff like that. And they go really deep on the stuff. To me, like always, experimentation, A/B testing, and causal inference, contextual bandits, like how do we make decisions better with data, has always been like the highest calling of data scientists in some sense. And so like the Sean Taylors of the world, I think of as like the archetype of this model.
Yeah. We've had him on the show.
I am not surprised by that. Yes, he is fantastic.
Yeah, he is fantastic. He was in episode number 617, and he very narrowly missed being in the top 10 most popular episodes of 2022. He was the 11th.
Yeah, he actually mentioned that to me when I told him I was coming on the show. He just wouldn't. He was like so broken up about it. He was just anyway. I don't think anyway. He may be broken up about it. I'm not sure, but he didn't mention.
Well, at the time that we're recording, he doesn't know yet. I haven't. That episode hasn't been published yet.
haven't broken it to him. Okay, got it. No. That's good. So that's one. That is one route. Another route is sort of to become like a very deep domain expert in some problem area. And there's a data scientist I worked with at Slack named Ravi Menon, who went to become like the VP of like all of data at Slack at some point. And his thing initially was he was the expert on the domain of Slack's pricing model. So like Slack had a usage-based pricing model like back in the day, which, and now there's like all these product-led growth companies who all do this. But at the time, it was a very sort of novel and innovative idea. And Ravi became the kind of absolute unquestioned expert on like Slack's pricing model. How did it translate into like the core business metrics of MRR, ARR? How did it relate to our enterprise deals? Like he really just became like, this was like his thing. This was his domain, obviously like super, super important to the company. And again, there are things like this for folks at Google, for folks at Netflix, like for all these different things. There's an area where like there's this really, really important, very, very quantitative business domain, and like the data scientist owns it. And then they expand beyond just being like the data scientist for it to being like the leader for it. And that's sort of like the next path. And then there's the final path, which is the one I took, which is the like data engineer in denial. And that was more or less me. Like I had done like a little bit of statistics and stuff like that as part of my graduate school stuff and my undergraduate stuff. But really, I was just like a software engineer who had not like discovered software engineering. And to me, honestly, John, in terms of like the engineering work I've done, like rebuilding Slack's search indexing pipeline, which is the pipeline that powers like the backend indexing system for Slack search, is still to me like the thing I am most proud of, like by far. Like that was it was so hard. And it was like every possible nightmare data pipeline problem you can encounter, we would encounter like a million times basically because of the volume and the scale of the data and stuff. And I love that, man. I love that. That was just such a favorite to me. And so that was like my favorite thing I got to do. And so I feel like my whole career was like working my way towards like kind of finding that problem and getting to work on it. So yeah, those are my big three. So data scientist to me still super useful, especially for generalists, especially at like early stage startups, but still like to me an unstable kind of profession, not something that you can maybe do. Like and inevitably, I feel like you gravitate towards one of these sort of three different outcomes of like super, super quant researcher, causal inference, experimentation, domain expert in some sort of quantitative domain, or finally like just data engineer, because back to the theme of like high quality data, simple analysis on it just really solves like a large set of problems. So yeah, that's my answer, man. Yeah.
I usually come in and like recap, on these complex topics, especially if it's like an enumerated list. I love
Yeah.
coming in back in and being like, number 1, number 2, number 3. You just did it.
Sorry, I didn't even think about it, but yes, exactly. That's right. Yeah.
Stop stepping on my toes, Josh.
I know. Sorry, John. Sorry about that. It's your show, not mine. Anyway.
I get to summarize.
Mm-hmm.
You introduce, I summarize. Come on.
It only seems fair. It only seems fair.
I love it. Those definitions are great. Makes perfect sense to me. And I don't need to recap it for the audience. It's perfect. We can move on.
Just leave it there. Oh, great.
Yeah,
cool.
We can move on to the next topic. So we've talked about your course and how that relates to data quality. We've talked about how you're famous for coining data scientist, and that's led to this very interesting discussion of what data scientists really are. And how the definition it's too broad. And I agree with you. You don't really have a sense of what somebody's doing.
It's a starting point, but it's sort of an amorphous thing. It's a blob, and it can go in any different ways. And I think you should go into it like thinking that that's going to go one of those 3 ways would be my Anyway, like people go do consulting. Like what the hell? Like they consult for Bain or McKinsey, and like what the hell is that? I have no idea. It's the same kind of kind of job. Yeah.
Well, so now let's dig into what you have been doing very specifically.
Okay.
In your past role. So up until recently, you worked at WeaveGrid, which leverages machine learning to decarbonize transportation.
Yes.
Sounds super interesting.
Yeah, absolutely.
How did you get into that role? What did you do there?
Yeah, for sure. So I got into the role. So I guess I left Slack in November of 2019. And I took some time off, and then of course the pandemic happened and stuff, and we can talk about that later. But I had been feeling for any number of years like I should do something to help the climate as best I could. And so I was like a lot of other people in tech, I was very focused on like climate and like how can I help? And I think one of the main challenges I think a lot of us discover is that there aren't actually that many ways for us to help. Like, just be perfectly honest, like there's a lot of fantastic work is being done. By a lot of scientists, by a lot of policymakers, by a lot of people and stuff like that. But it's not like there's not like some super hard machine learning problem at the core that if we cracked it, like would solve everything, right? So we kind of have to help on the margins, right?
We've had a couple of cool episodes about this. It's a while ago now, but in the spring of 2021, so 2 years ago, we did 2 episodes in a row, number 459 with Vince Pataccio and 461 with Sam Hinton, where both of them talked about this, like how they are using data science or how you could be using data science or machine learning to tackle climate problems. And it's exactly as you say. It's not like AI or like finding, being able to crack artificial general intelligence, where clearly working on data science is going to directly be involved in that. It's like with climate change, it's on the periphery. It's not like, oh, great work, you made that model and now nuclear fusion works.
Yeah, I mean, precisely, exactly. Which, I mean, maybe someone's doing that, which would be great. Like, let's throw a deep mind at like stabilizing, the magnetic, the tokamaks or whatever, however you say that stuff.
I say that
someone's doing that. Maybe
I make that joke, and literally we had Dr. Brett Tully come in an episode of 533 and talk about exactly that.
Exactly.
He was using data science to simulate aspects of how fusion could work. But yeah, it's nevertheless, it's not. There are various kinds of fringe problems, ways we could be using data science, and all of those add up, of course.
Yes, they do. I guess I think of it in terms of like, at least with WeaveGrid, is like there will be second order problems as a result of how we approach things. And then the question is like, how do we address those second order problems? So WeaveGrid's like focus is addressing a second order problem that arises with the growth of electric vehicles. Which is that we are now going to have, like over the next decade, like a ton more electric vehicles. 85% or so of charging of electric vehicles happens at home. And a sort of proper level 2 charger, which is like something you need to kind of like fully charge a car from 0 to 100 over the course of an evening, draws about as much electricity as 6 refrigerators. And so the base load that the grid is going to have to support is about to go up significantly, like will go up significantly over the next few years. And the grid is, first of all, like the electrical grid is like one of the engineering marvels of the 20th century. Like, and in fact, there was like some kind of survey or something, and people said, yes, actually, that was the greatest human achievement over the 20th century, was building the
Oh,
electrical grid.
yeah, yeah, yeah.
But the electrical grid is not built for a world in which residential, in particular, like electrical use is going up. Electrical use residentially has been going down in America for pretty much my entire life. Like it peaks back in 1980 because everything is getting more efficient. Our refrigerators, our dishwashers, everything is laughably, comically, insanely more efficient, right? And so EVs are going to disrupt that. They're going to change that. They're going to like shake up the system and shake up this gigantic machine that is not especially smart. The grid is very good and very stable, outside of Texas. Sorry, I couldn't help myself. I was digging in Texas, but nonetheless, my other sort of nerdy issues with Texas and their approach to the grid stuff. But anyway, but it's not a smart system. It's a dumb system, and so it's not aware of like there are cars and those cars can be connected sometimes and not connected sometimes and stuff, right? So the question then is like, how do we leverage the internet and all this computer technology that is built on top of the grid, by the way, to make the grid smarter? Because the reality is we can like analyze all this data we're getting to see where the electric vehicles are. We can anticipate when electric vehicles are going to get home. We can anticipate how much charge they're going to need when they get there. And if we can anticipate these things and we can plan for these things, we can ensure that when they do come home, when they do need charging, the grid keeps working. We don't overload the grid, which is again, like some places in San Francisco in particular, where we have like a absolute, ton of electric vehicles, Teslas in particular. We have to change out the transformers and the substation infrastructure because like the grid isn't built to handle like 20 EVs on one block. Like it's just not built for that, right? So this is like what WeaveGrid does. Like this is sort of their business, is like they are building the systems that we need to do what is called managed charging. Managed charging is essentially ensuring that for all this charging that's happening on the grid, we can schedule and optimize all of it so that we don't ever overload transformers, substations, all that kind of stuff. We keep things under kind of the rated limits for this stuff so that it doesn't wear out too quickly, while also simultaneously making sure everyone's car gets charged and people get where they need to go and all that kind of good stuff. Yeah, that's the business. It's kind of, I don't know, man. It's just, to me, it's just like a nerdy, fun, exciting time. Like these two gigantic monster industries of utilities and car manufacturers are like colliding into each other. Like, and they're just absolute beasts between the two of them. WeaveGrid and a few other folks, just these little tiny companies right there trying to like, smooth out the integration between these two things. It's just kind of cool. So yeah. I built a lot of their infrastructure when I was there. Like I was like data infrastructure, obviously, but like the vehicle monitoring systems and the very first managed charging system. I built it with the one WeaveGrid ran for one of our utility partners. I wrote, and that was like, again, kind of, absolute honor, privilege to get to have the opportunity to do that. Anyway, it was like super, super fun. Really, really cool stuff. Yeah. That's
Yeah,
it.
it sounds amazing.
Yeah.
I love that and this is a recurring theme in your career, and we might as well dig into this right now,
Oh, sure.
is that you've dug really, really deep. So whether you were at Cloudera or Google or Slack, you dug really deep into solving those companies' problems with respect to data analytics, machine learning. And then you would kind of come up for air
Yeah.
and find something really meaningful to tackle, whether it's reading 50 books on decision making
It's a
or
midlife
tackling
crisis,
climate
John. It's a midlife
change.
crisis. Yeah.
Yeah.
Anyway.
Tackling climate change, tackling the COVID pandemic. We're going to get to that later on.
Yeah.
So it seems like, I don't know if it's exactly like interdigitating, like flipping back and forth between the two, but this idea of, digging into something really big commercially for a while and then finding something more meaningful to contribute to, taking these kinds of sabbaticals like you're taking right now. We're also going to
Yeah.
get into that later because what you're doing in your sabbatical right now, other than your course, is fascinating. The kind of the open source work that you're doing.
Yeah.
And so I guess, do you want to comment on this approach of taking sabbaticals, and is it something that you'd recommend to people in general?
It's a great question. That's a great question. It's something I am extraordinarily privileged to be able to do, I think. Without a doubt. I feel very, very fortunate that Google and Cloudera and Slack have afforded me the freedom to do this. Yeah, and I just, in some sense, John, it's kind of feels like the absolute least I could do, you know, right? Like the very, like the, yeah, to be so privileged and then like, yeah, contributes like back to humanity sort of wherever you can. I think a lot of it, like honestly, man, it's just like I got a kid, he's 7, right? And the other thing with the pandemic, at least out here in San Francisco, was in September of 2020, the sky turned orange because the wildfires were so, you remember that, I'm sure it was a big national news thing, right? And I will never forget getting woken up by my son on that day. Like he's like, he has a, timer in his bedroom, so he can't wake us up before 7. And he wakes me up and he's like, Daddy, it's 7, but it's still dark outside. It's like, oh my God. And it's like, living in the post-apocalyptic kind of
What do you,
thing.
what do you
So
mean he has a timer in his bedroom, like locking the door or something?
no, it's not locking the door.
He literally
It's not.
he literally cannot disturb
No.
us until 7 o'clock when the timer goes off.
No, he absolutely can. He absolutely can. It's just that when the light turns green at 7 or whatever, he's allowed to like come out and like watch TV or whatever, like that kind of thing. That is the rule.
Mm-hmm.
Um, but yeah, like more than anything, it's like when I imagine a future in like 10 or 15 years when he asked me like, Dad, what were you doing when the sky turned orange? And I like wanted to have a good answer. wanted to have a good answer. So more than anything, I think it's like, I don't know, like it seems like the regret minimizing way of living your life is like when your kid asks you what were you doing with your time, like having a good answer is kind of what I'm after, more or less. Yeah. So that's my framework these days. Yeah.
I thought the way
Yeah.
that you were going to go with that was like making a better world for him, but it's just about avoiding regret.
It is about avoiding
Yeah.
regret. It
That's
is. I
an
mean, it's like,
honest perspective.
yeah. Well, it's like Warren Buffett said something to the effect of like, and when I was reading all those, decision making books and stuff, read a lot of Warren Buffett, a lot of Charlie Munger, a lot of Berkshire Hathaway stuff. Is like Warren Buffett, like what's success for you? It's like the people who you want to love you back. That's what you want. That's success. And I'm like, that's a very useful like framing of the problem. That sounds pretty good to me. So yeah, working in that direction, absolutely.
Cool. So yeah, well, now we'll flip back to just really nice, cold, hard commercial data stuff.
Awesome. Thank
Right?
God. Ooh,
So,
much more comfortable there. Yeah.
so before WeaveGrid, you worked at Slack. We've talked about that. We've
Yes.
alluded to that. You were their first director of data engineering.
Yes.
And then you discovered in that role that you don't like management.
Not that much. Not that much. Yeah.
So it sounds like from footage that we found of you speaking that you essentially demoted yourself.
I don't know. So I don't know if demoted is the right word. I think in the tech in the tech industry, we try not to say that like people harp on this, right? It's a big deal about like IC and management are
independent contributor track versus management track.
It's exactly versus the management track or lateral moves. It's not a demotion.
Yeah.
And I would say like Slack was a place where these kinds of moves of folks going into management and saying, you know what, this is not for me, was very much like tolerated to the point of being encouraged. Like my manager, like my director counterpart, who was ahead of all of our platform engineering stuff, he left management to go back to an IC role like a couple of like maybe a month or two before I did. You know what I mean? And there were just a bunch of friends I had there who did that same kind of move. Like Slack, I think to its credit, took engineering management very seriously, like very, very seriously as a practice, as a discipline, as like a thing you were serious about, in a way that like I think a lot of other tech companies don't necessarily, where it's like, oh, just it's a thing, but like really it's the tech in the building that's the important stuff, right? And Slack was not like that. And that was a great place and a great environment to discover that something was not for you, because there was no like, you couldn't like, I feel like a Google, for instance, like there's this sort of notion of a tech lead / manager where these two roles are kind of intertwined together. Slack does not have that concept. There is a tech lead who is person A and there's a manager who's person B, and they are counterparts and they work together, but it's not the same person. And there's costs that go with that. The communication costs obviously go up significantly, but there are a lot of benefits as well. Like you don't have this problem. Like I think a lot of sort of abuse and sort of bad practices we see in employment is when you have one person who has essentially like complete power over the control of the career of someone else. And Slack didn't have that because there was a tech lead and there was a manager, and they were both important, right? And they both played a role here. And so anyway, like there were virtues to Slack's approach here. So yes, I guess I was at a culture where, like, quote, demoting yourself or moving back to the IC role was not a thing. It was not a big deal. I was fortunate as to be like not so far into my management career. I talked to a lot of people who are like who want to do this, basically, who like, like, Josh, the joke I made at that one of my talks was, engineering management is a pie eating contest where first prize is more pie. Like if you just go kind of up higher the management hierarchy, there's just a lot harder management problems up there. It's not like it doesn't get fun at some point, right? And so a lot of folks want to leave management and go back to being an IC, but they're afraid that they can't. They're afraid they've been doing it for so long that they're afraid their skills have atrophied and stuff like that. And they might be right. I'm not really sure. I don't know. I just know that I did not do management long enough, and I didn't do it well enough for my technical skills to really atrophy. I kept doing tech stuff pretty much all the time, right? And as a result, it was a pretty easy transition for me. So I don't know. It's only a hero thing to the extent to which if your identity becomes wrapped up in I am an engineering director, I am a VP of engineering, this is who I am, like this is me. And then if your identity, like, and your sense of self-worth becomes wrapped up in it, I get why it's super hard and super scary to leave. It'd be terrifying. I get that. And to tie this to an earlier conversation, I think one of the advantages I felt like I've always had as a data scientist, or identifying as a data scientist, is I've never been embarrassed to not know something about software engineering. Like, because I don't know a lot of things about software engineering, because I know, learn a bunch of stuff about statistics. And simultaneously, I've never been embarrassed not to know something about statistics, because I'm not a statistician. I'm not a software engineer. I'm a data scientist. Like, my job is the intersection of these two things. My job is to be able to like ask intelligent questions of people on either side of this divide who know a lot more than I do. And like, it's fine. That doesn't threaten my identity. Doesn't mean I'm a bad software engineer or a bad statistician, because I'm not that. I'm a data scientist, right? And that has always been, I think, like figuring out like a sense of identity where like you have the privilege to ask stupid questions to people, like is very much a superpower. Like kind of like being a podcast host, I would imagine. Like it's anyway, yeah.
I do get to ask a lot of questions.
Good.
And I am comfortable not knowing a lot of things. That's why your quote, which you just referred to again, your really famous tweet from a decade ago, coining a data scientist. That's why it resonates with me so much, and why I use it all the time.
Good. I'm glad. Yeah, that's awesome. Yeah.
Cool. Well, so that really answers. I had lots of questions for you about engineering teams and independent contributor versus management track, and you answered all of the further questions I had on the topic for you. So
my favorite, if I can have a line there, my friend Keith Adams, who was the chief architect at Slack, was just said the nicest thing to me ever. It's like one of my favorite compliments. It says, Josh was far too good of an engineer to be wasted in management. And like that was, again, like heart explosion, kind of like nicest things people have ever said about me. That's by far one of my favorites. So yeah.
Nice. It's kind of how somehow the other way around sounds like an insult, where you're like, look, you're too good at management. We got to get you away from the engineering.
Yeah, exactly. I mean, that's some truth to that, I think. Exactly. Anyway, yeah, there's definitely pejorative versions of it, but I think it was a nice counterpart to the sort of notion of demotion, I think, is what I want to say. Is at least in Keith's sort of hierarchy, the IC engineer was a higher status role than the manager director role.
Oh yeah, and you see that in meetings all the time, where you have the IC is often, or the tech lead, as you described it, is often in meetings clearly the person who understands this problem best and is the person that you should be listening to. And a lot of being a good manager is just listening to that person's opinions and making sure that their perspectives are propagated through the organization effectively.
Indeed. And then again, and sort of the reverse thing too, making sure that IC, that tech lead, has the context on the business and everything else that's going on and stuff that is just your job as the manager to keep track of and keep a pulse of, so that they can be as informed as possible, right? And I was not good at that latter thing, because I didn't really care about anything that was happening in the organization that was not like the data stack. And so I was not the person to be, it just wasn't the right thing for me to be doing. Just that simple. There's a lot of stuff about managing I love, by the way. I love hiring. I love talking to candidates. I love understanding someone's narrative arc, understanding like their hero's journey, like where are they, like what do they want to be when they grow up? How do we help them get there?
Mm-hmm.
I love one-on-ones, like I think every sufficiently like senior job is essentially like a therapist more or less. And management is a lot of, just listening to people like, discuss their problems and stuff like that. These are all things I loved. Sprint planning, not really for me. Like I just want to kill myself, like sitting through sprint reviews and stuff. I can't do this. I hate this. Yeah.
The therapy thing for sure. And
Yeah,
one-on-ones can be super rewarding.
absolutely.
I have a friend, I won't even mention where he works, but he works at one of the biggest tech companies in the US. And he is an amazing software engineer, grew to a very high level of management, and eventually realized that he was basically only a therapist. That was what he did as a job. And I think what helped him realize that is that his partner is also a therapist, is actually a therapist, like
actually
is a licensed,
real therapist. Exactly. Yeah. Precisely. Yeah.
And
totally.
So it was, I think they were getting home and having these conversations with each other and being like, our day was the same.
Yeah. I have CEO friends who are like, yeah, I'm basically a therapist. That's more or less like if I was to do it over again, like the best CEO training, I think, is to be a therapist.
Mm-hmm.
Yeah. Quite
Come into my office, sit down, tell me what's wrong.
Pretty much.
How can we work on
it? That's the job. Exactly. Yeah. And then for customers and for everybody, like not just your direct reports, not just everyone at your company. Yeah. Everybody. Yeah. At least the folks who are good at it are just great listeners. Anyway. Yeah.
Yeah. So great listening, hiring. These are things that you've done not only in Slack, but also you led teams at Google. I just blended together Cloudera and Google.
Yeah, exactly. I was like, Cooley. Exactly.
Yeah. So yes, you led teams at Google and Cloudera in addition to Slack. And at all three companies, you were there when they grew massively. So how did you keep up with those pressures? External pressures, internal pressures. How did you ensure that your team met expectations, that kind of thing?
That's a great question. I worked super hard. I don't want to say I worked all the time. It's don't. I mean, like I wish there was a great, it was like, oh, John, it's my 3-step guide, and you can buy my book to learn how I did it. It wasn't. I mean, I had no work-life balance whatsoever for like the better part of a decade. I kind of like reflect on, especially those 2 years at Slack where I was like building the team, building the infrastructure, like the first couple of years there. And I'm like, I don't really remember anything, John. Like, it's just kind of like a blur to me because I wasn't sleeping. I was just like working all the time, and I had like a newborn and stuff. And it was just like, it was just so hard. I don't understand. I don't remember how I did it, honestly. I love work-life balance and stuff. And I love again, getting to be a dad and like getting to just go to basketball practice and stuff like that. Like I love this stuff. Simultaneously, I have to be honest, and this is something else I'm cribbing from Keith Adams as well. I have to be honest about the fact that the only reason people listen to me, or like I'm a guest on this podcast show, is because of things that I did when I had thrown work-life balance completely out the window and like worked obsessively. I once worked 24 hours straight on my birthday, like in my 20s. Like that was just like how like absolutely obsessive I was, right? And I like look back at that and I cringe. Like, oh my God, like what was I thinking? Freaking idiot. But yeah, that was what I did. And I mean, I don't know. I loved it. I think for better or worse, I lived and breathed this stuff. I think I thought when I was at Google, I thought about Google like nonstop for like 4 years. I mean, when I quit, when I left, I was at my last job at Google. I was working on like building the data infrastructure for what eventually became Google Plus. And I was massively unhappy and like just super depressed. It was for any number of reasons. And I think it was like when I finally quit, I remember like it was I was super busy like quitting. Like quitting was very time consuming, like giving notice and quitting. And then like I remember that first night where I was no longer employed by Google, like having a panic attack basically because like my whole brain had been thinking about Google constantly for 4 years, and then it was like that was no longer an option. I was like, I mean, I could think about it all I wanted, but there was nothing I could do about it anymore. Right? There's nothing left to be done. And like, yeah, just that really sort of painful, horrible night. Yeah, man, I guess like I said, there's no tips or tricks. I did all the unhealthy things you do when you don't know the tips or tricks. That's what
Well,
I did.
you say no tips or tricks, but we did dig one up from a talk
Oh,
you've
okay.
given at ODSC.
Oh, all right.
So
Okay.
you talked about how good decision making needs a lattice of
Mm.
mental models.
Yes, that's true. That I did. And that was part of my like kind of after all of that stuff. I think like when I started coming up for air a little bit. Especially like I was so I was at Google for like 4 years and then Cloudera for 4 years and then Slack for 4 years. And so like this is a 12-year period where I worked more or less continuously for these companies doing this stuff. And my last year at Slack, I was just just deeply and profoundly fried and burned out, like totally burned out. It was they were again very kind to me, and just let me kind of hang out for a year. Like basically, I don't think I did much of like useful stuff during that last year, but nonetheless. Um, and I got into like the Farnham Street community and like sort of general like decision making kind of stuff. Like so Thinking in Bets by Annie Duke, and then a lot of stuff around like Charlie Munger, like Warren Buffett, like that kind of stuff that I talked about before. And that was what led me down, like getting super super interested in like how do we make decisions? How do we make decisions as individuals? How do we make decisions as organizations? What makes for effective data teams? Like why was data so easy at Google and so hard at Slack? Like stuff like that. Why did it work at some companies and not others? Like all these kinds of things. And so I think more than anything, what I came to realize, I think for better or worse, I am very like Google very much shaped me. It really like they took me as like a fairly like unmolded, whatever bit of clay, and they turned me into what I became. And so I kind of came out of Google fairly unapologetically data, experimentation, OKR, all the things, kind of like zealot, basically. That's what Google turns a lot of people into that. And at Cloudera, I kind of like preached that gospel. You know what I mean? I was like, really, it was like Hadoop and MapReduce and then Spark and all that kind of stuff. But really, it was about like, we can use data to make better decisions. If we use these tools, if we do this stuff, we can make better decisions. And so I was the prophet of that. And then when I got to Slack, I kind of collided into an organization that really did not work that way. They really did not use data to make decisions. It was very much like driven by vision, intuition, design principles, like things that were not like things that Google, I would say, like put relatively less emphasis on, I guess would be the nice way to say it, I guess, when I was there. And so that was very hard for me. That was like a culture shock to go to Slack and like say and discover that like there was this other way of working that actually like kind of works pretty well and has like a lot of virtues to it and stuff. And it doesn't actually have like not everything has to be A/B tested and stuff like that, right? And so kind of on the other side of that, that was what led me to kind of a much more integrated perspective on decision making, where it's not we don't just hang our hat on one thing. We combine any number of things together. In order to come up with the best decision. It was funny, John. There's a great the book about what was it called? It was about the Houston Astros. It was the book the guy wrote about the Houston Astros and like their sort of journey to the World Series. And I gave a talk about it. It's one of my talks from 2019 is about the talk is called How to Play Well with Others. It's one of my favorite talks. It's like one of my favorites. But it was talking about how the Houston Astros integrated kind of Moneyball, very metric style stuff with like more qualitative measures and stuff like that. And that sort of has become kind of my dream aspiration, I think, is like, what is an integrated sort of like design, user research, like data science kind of perspective on these problems look like and stuff like that. Like how do we sort of tie all these things together to make better decisions as a whole? Is kind of my great sort of curiosity and obsession right now. It was a bummer that the Astros apparently cheated to win the World Series or something. It kind of like blew a hole in that otherwise awesome narrative. So I'll never forgive them for that. But nonetheless,
The three pillars of success in the lattice of mental models are a quantitative approach, a qualitative approach, and cheating.
Yeah, I get it. I mean, exactly. That's basically it. You need a lattice of mental models, precisely. Like exactly that. Yeah.
Out of the box thinking. How can we break this?
I mean, exactly. And an absolute like sort of willingness to win no matter what. Apparently, I don't know. Mm-hmm. Yeah, I don't know.
New England Patriots. Similar kind of thing.
Yeah, I mean, it's sort of an interesting question here. Yeah, exactly. Like, to what extent, when does like quantitative or sort of like obsessions with winning kind of lead us down these sort of like morally dark paths, right? Like, when is it? And I'm not, super happy with all the things Google has done since I left. I'm not super happy with some of the people who are still there from when I was there. And anyway, things have certainly gotten darker over time as the need for more profit, more money, all that kind of stuff. But so I mean, twas ever thus, such is life. Yeah.
I mean,
Anyway,
they literally dropped the "Don't be evil" slogan.
they did. They did. Except they felt like it was holding them back. Yeah. To a certain anyway.
So
Yeah. Yeah.
yeah,
Yeah.
so
Anyway.
we talked earlier in the episode about how you've kind of flipped between the commercial kind of work, like at Google or
Yep.
Slack, and so let's flip now back to something you did that I think we can say is unilaterally not evil,
Yeah.
which is
Yeah.
that at the start of the COVID pandemic, you were asked to be part of a team of volunteer experts assembled to build tools for modeling and forecasting the early stages of the COVID-19 pandemic in California. Can you tell us about that experience and what kinds of tools you used? Like the problem you were faced with and how you tackled it?
Yeah. Yeah. Absolutely. Absolutely. So I think, it was obviously a scary time, I think, for everybody. So it's like you really kind of got to the extent that anyone wants to transport themselves back to March of 2020, you kind of have to kind of go back in time to when we didn't know anything, and we're just sort of doing the best we could in the face of a very new and very, very scary disease. Sort of took over the world for a bit there. I was unemployed. I had left Slack in November 2019, and so I was just kind of hanging out with not much to do. And my old friend DJ Patel, who's used to be the chief data scientist at LinkedIn and chief data scientist of the United States, still very like plugged in, networked into governments and all that kind of good stuff. Gave me a call and was like, "Hey, Josh, we're assembling a team to help out the Department of Public Health in California with their sort of forecasting. We're trying to figure out everything. We're trying to figure out like, what sort of lockdown, what sort of like shutdown system do we need? Where do we need ventilators? Where do we need do we need to convert a stadium into a hospital? Like, what do we need to do basically?" And so they were working with a team of epidemiologists at Johns Hopkins, like basically like postdocs, PhD students who honestly had been, living this nightmare for like a lot longer than I had and had not slept, and had been essentially like running these models, like running these forecasting models, prediction models of like how the pandemic would go continuously for weeks. And our job, like what we were sort of called in to do, myself, my friend Sam Shaw, a few other folks who were generally like ex-Obama White House people that DJ had known from his time there, um, was to like relieve them and give them a hand and help them out with anything they needed. Because yeah, it's like really what we were doing was like, so I was effectively doing, I think I was for a brief period of time, I was like every data scientist's dream, which is that I was your software engineer who was here to do anything you needed. Anything you needed. I was at your beck and call. I was your chat GPT, just to mention it one more time in this talk, right? Um, I am here at your disposal. If you have an optimization problem, I am here to help. If you need, and this is kind of what we did. We took the software they were running on a big machine at Johns Hopkins, and we like Dockerized it, containerized it, structured it into kind of a proper pipeline, and we just again, like literally the early stages, Sam and I were just like swiping our own credit cards at AWS to buy the biggest machines we could find to run like just more and more and more versions of these simulations basically as fast as we could so that we would have some idea of what was about to hit us, like what was our best understanding of like what was going to go down. And it was like, yeah, it was a crazy 48 hours from when I started the project to when we like presented our results to the governor and the governor's staff and stuff like that, like right before he shut down the state of California. And I was like, yeah, I was
Wow.
like nothing, like absolutely nothing like it. Like just, you know, anyway, I was talking about like the decision making stuff was like the midlife crisis, and that experience, that 48 hours was the cure. I don't really ever have to worry about like was my work meaningful,
Right.
kind of ever again. It was deeply meaningful to me. Um, yeah, that was what we did.
Nice. I love that story. I've loved this journey through your absolutely fascinating career. So back to the present,
Yes.
what kinds of tools do you end up using day to day? Like, what's your personal tech stack like? You've mentioned a
Mm.
lot of different really great
Yeah.
tools
I've done a lot of
throughout.
stuff. It's true.
Yeah, yeah,
Yeah.
yeah. But
Yeah.
like day to day, what's kind of like your bread and butter?
I've gotten into sort of much more sort of small scale stuff these days. So I don't do much in the way of distributed system stuff anymore. Computers have gotten really good. My latest fascination, which I think a lot of folks who follow me on Twitter would know about, is DuckDB. DuckDB is the way it's described. If it's sort of like SQLite, but for analytics for OLAP. It's a very very fast, very small embedded.
OLAP?
Online analytical processing, data warehousing kind of stuff. Like when you're doing like typically speaking, a database is either row oriented, like MySQL or Postgres, where data is stored row by row and it's very fast to do kind of point lookups of a row, or in a columnar fashion, which is the way like Snowflake and Redshift and all this kind of other BigQuery, they all store data in a columnar fashion, where it's relatively expensive to load it because you have to convert all the data to the columnar format, but then it's very fast to query and do aggregations and stuff like that on that. So SQLite is an embedded OLTP database. It stores stuff row by row. DuckDB is an embedded OLAP database. It stores things and kind of operates on data in a columnar fashion, like a data frame, effectively, right? So I do a lot of work around DuckDB, mostly in Python. I work on the DBT adapter for DuckDB, which is called DBT DuckDB, which is a lot of fun and a great source of joy for me. I'm trying, like John, to build or kind of rebuild or reconceptualize what does a data warehousing stack look like in a way that takes advantage of all of this like sort of fantastic web server technology that we have developed over the last 20 years or so. Like Postgres was kind of born before the web, right? In some ways, like Postgres has its own protocol. It's not HTTP and stuff like that, right? It has its own auth system. It has its own all this kind of other stuff. And I'm very curious about the idea of rebuilding this stuff now out of like these individual components and kind of reassembling them together and sort of seeing what I come out with on the other side. I would like to build a radically cheaper, like $1 a month kind of cheaper, like data warehousing sort of stack right now. This is my sort of weird obsession. This is not a good business. If you're in a business where like, the stack costs $1, it's kind of hard to make a living doing it. But it's something I'm just deeply curious about, and I'm trying to like figure out. So that's kind of broadly what I'm up to these days.
It sounds like it could be disruptive. And then there are good business models around that where if you can build, so kind of like Wes McKinney,
Yes,
you can
with
build open
pandas.
source, with Pandas, and then more
Yeah, and
recently
Arrow.
with Apache Arrow. Yeah.
Arrow. Yes,
Um,
exactly. That's right.
so you
Totally.
build these open source tools that are highly disruptive, but then you can charge consulting fees to help people implement it and take advantage of that disruption.
Totally. Exactly. Whether or not that's how I want to spend my retirement years or not is kind of a question. But for the time being, like this is the problem I'm like obsessed with solving. So this is what I'm working on. Yeah.
That sounds awesome. And I'm sure
Or at least
what,
maybe like figuring out if it's possible, I guess is probably a
yeah,
better way
yeah.
to say. I'm going to solve it, but like, can this work? That's kind of what I'm curious about. Yeah.
Yeah. And even just solving pieces of it could be game changing.
If anything, it's like a very interesting problem and it's just super fun for me. So that's how I spend my time these days. Yeah.
So yeah, I'm sure our guests, just as I am, are confident that whatever happens with this project or whatever happens next in your career is going to continue to be extremely interesting, just like
Yeah.
your path has been so far.
Oh, thank you for that. As I said, I've been very lucky, extraordinarily privileged to have, to get the chance to do this kind of stuff, and obviously happy to be at the disposal of the next major crisis disaster that needs some data pipeline optimization.
Nice. Let's cheer for another crisis.
Yay! That's not great, really, unfortunately.
No.
Yeah.
So near the end of every episode, I ask for a book recommendation, and with
Mm.
all of the amazing topics that we had to cover about you,
Yes.
we didn't even mention that you have a book. You have
I
a
do.
book called Advanced Analytics with PySpark. It was published by O'Reilly in 2022. So it's a
Yes.
relatively recent book. And yeah, you want to tell us a bit about it?
Yeah, so it's actually it's the third edition. It's an adaptation of a book that I wrote when I was at Cloudera with my Cloudera data science team with Shano and Sandy Riza and Uri Laserson back in 2014. Believe it or not, it was the first. It was written for like Spark 1.0, which was maybe even prior to PySpark actually existing. It was done in Scala and stuff like that. And so yeah, it was just a sort of collection of some of our own favorite patterns and libraries and stuff like that for doing advanced analytics with Spark. And then did a second edition of it, made some fixes and some changes and some evolutions. And then a wonderful young man named Akash Tandon came along and redid the whole thing in Python. So adapted our stuff in Python, modernized it, and then like cut a new release of it. But it's still still one of my absolute favorite things I've done. I tried to, it was, there's a lot of things in life, John, where it's like the experience of doing them is awful, but you're glad that you did it. And like writing a book is pretty high on the list.
No,
Right?
I've written a book too.
Right? You've written a book. It's like, exactly. Yeah, totally.
Up until that point, the worst experience of my life was my PhD dissertation.
Yeah, okay.
And
that sounds much worse.
The book was worse. A book is worse because you know, or you hope that at least someone's going to read it, which at least with a PhD dissertation, you don't have to worry about that.
That's right. Exactly. It's just going to go on a shelf somewhere and like never think about it again. Exactly. Mm-hmm. Exactly.
So yeah, it was horrible, but absolutely. It's one of those things. Do you ever think about things, or have you heard of this like framework of type 1 fun versus type 2 fun?
No, I don't know this. I don't know this framework.
It's really simple.
I should have covered in my decision stuff, but yeah, go ahead. What is it?
Yeah. It's really simple. And I don't know if this ever was like officially coined in a book or something, but it's something that with friends I've been talking about for at least 15 years. And I remember the first person who mentioned it to me. So it was while I was doing my PhD that somebody explained this concept to me. So type 1 fun is what you traditionally think of as fun. So it's like something that directly stimulates dopamine, serotonin production, like partying, driving a car fast, sex.
Doing cocaine, exactly.
Doing cocaine is probably the most direct,
very direct.
Type 1 fun. Yeah, you're like, just put it in my veins.
I did neuroscience stuff in undergraduate, by the way. Like that was I thought I was going to be a brain scientist back in the day. So I love all the anyway, that's great. Yeah.
My PhD was neuroscience.
That's awesome, dude. We could have done a whole section on neuroscience.
We're gonna have to.
This is a shame. You could have like caught me up on like what's going on with the basal ganglia. Like, are we still some other time? Anyway.
Yeah. I mean, I finished my PhD a while ago, 10 years ago, 11 years ago. So I don't know. What
I stopped doing the research like 20 years ago. So you're still up on me. Anyway. Yeah.
Yeah. It was my slippery slope into data and machine learning. Working with big data sets like genomics data, really, and brain imaging data.
Yeah.
And so there was an abundance of people in our university, in Oxford University, creating large amounts of data, and there weren't enough people around to do something, to find patterns in the data. And so I was able to get a bunch of papers and actually, frankly, awesome. I mean, I don't know if this is still like a hack that you can do today if you're doing a PhD in like in a lot of scientific fields, but specializing in data science is like a hack because people will spend years literally creating a data set. And then they're like, I don't really know how to analyze this. They're like, I think I see this pattern here. Like if I graph it, I can see that like there's this and that, or I know from my many years of working with ferrets with the like electrode implanted in the brain that there's this particular effect. Exactly. But they're like, how do I prove this statistically? And I'm like, well, so like there are instances from my PhD where I did less than a day of work, but was one of the first authors on a paper because I was able to just be like, well, you need to just do this test.
Do this thing. Exactly. It's like not even that hard, right? Exactly. That's fantastic. That's some leverage right there, man. That's good stuff.
So anyway, how did I get down this path?
The type 1, type 2. So what that was type 1. Type 1 is dopamine. And then type 2.
Type 1 is direct stimulation. Type 2 fun is this kind of thing, like writing a book or exercising, where while you're doing it, you're like, this is terrible.
This sucks. This is horrible. Yes, precisely. Yeah.
But then when it's over and you look back on it, you do get that rush of dopamine. Absolutely. You're like, wow, that was really great.
Exactly. That's right. You feel fantastic about it. Absolutely.
So, type 1, type 2 fun.
Okay. Bye-bye.
Anyway, so advanced analytics with PySpark, solid type 2 fun experience. I guess in that case, specifically that edition for a cache tandem, it was probably
Mostly type 2 fun, exactly, for him.
yeah.
For me, it was relatively light. It's editing and
Yeah.
stuff. Yeah, it wasn't so bad.
But
Yeah, exactly.
early like 2012, 2013, you were going through it.
That's right.
Getting the first
Exactly.
edition out.
Exactly.
So beyond your book, do you have recommendations of other books for our audience?
Oh, Chip Hoyne's book,
Yeah.
Designing Machine Learning Systems. I literally have it like right next to me, actually. Pretty here. I'm actually see if this is my autograph copy or my other copy. I'm not sure. I have a couple. So I saw Chip at a conference recently, and I had her sign a copy for me. So yeah. And then another one I just love because I'm actually like a history nerd as much as anything. Like I love the Robert Caro books, like all of them from the Power Broker, like the Lyndon Johnson series. Rise and Fall of American Growth was absolutely wonderful. Like highly recommended. There's also there's Brad DeLong Sloshing Towards Utopia, but like the kind of story of like economic growth and the change of an American society from like 1870 to the present is just like absolutely like mind-blowingly fascinating. And I just like thoroughly love those books. There's an older book. It's From Dawn to Decadence by Jacques Barzun, as a historian who also, I just like just books where like just the density of information and discovery and joy I find on each page is just like off the charts high. And like Rise and Fall of American Growth is the most recent one I read like that. So yeah.
Nice. You actually answered that question similarly to Chip, where
Oh really?
she reeled off. I mean, all of the books are different.
Yeah, of course, sure.
But she just had so many books that she wanted to talk about, which was really interesting in filming her episode because she was already over time. Like we had, she's the co-founder of a fast-growing tech startup.
Of course, exactly.
Her time is extremely in demand.
Yeah.
And so we were over. And like I told her before I asked the question, I was like, look, we've gone over time. So I know we need to wrap this up quickly, but I asked this question to most guests. So, just give me a quick answer. And then she spent several minutes going through all these books. She looks back over at her bookshelf, which is over her shoulder. It is like, there's that one, there's that one, and there's that one. So
that sounds exactly like Chip. And that's, yes, exactly why I love her. That's fantastic. Mm-hmm. I look forward to that episode. Yeah.
Yeah. At the time of recording, it isn't out yet, but it will have been out by the time people are listening to your episode. So that was 661. 2 weeks before your episode airs, 665.
That's awesome.
So yeah, very last question.
Yeah.
How do people follow you after the show? Obviously, you are a wealth of interesting information.
I try.
We've talked about your Twitter channel.
Twitter still exists, as long as I kind of got into a fun Twitter exchange today, which is like someone did like the Goodwill Hunting, like the Ben Affleck scene at the end analogy with me, which is like, that's my relationship with Twitter. Like eventually Twitter will die and I will be free. But for the time being, Twitter still exists and therefore so do I. So I'm basically like imprisoned there with the rest of the crazy people. I think my request, John, would be like for folks to follow me on GitHub. Like follow what I'm doing on GitHub, follow me there so as to motivate me to do the actual work I should be doing and not like shitting and like, like reply guying on Twitter, which is awfully fun, but it's probably not the best use of my time. So yeah, on GitHub, I'm Jay Wills, and that's where I'm also a gainfully unemployed data person. And like I said, hopefully where I'm working on stuff that will maybe someday, hopefully fingers crossed, be useful to somebody. So yeah.
Nice. I have little doubt. Josh, this has been the fascinating episode that I knew it would be. Thank you so much for coming on the show, and we'll have to check in with you in a couple of years and see how the dollar data warehouse is coming along.
That's I'm going to steal that, John. That's fantastic. Thank you for that. I appreciate it. The dollar data warehousing menu. Anyway, thank you so much for having me, man. This was tremendous fun. I really appreciate it.
What an honor to be able to learn from a legend like Josh Wills. In today's episode, Josh filled us in on how machine learning engineering is software engineering on hard mode because scaling, testing, and ensuring reliability are all harder, how contextual bandits randomly insert some results into users' feeds, allowing optimization of ML algorithms to occur an order of magnitude faster than with A/B testing, how simple analysis on a large amount of data is typically superior to sophisticated analyses on small amounts of data, how the infinite loop of sadness may be avoided through having data centralized under a single trusted leader, how electrical grids can be made smart with data and machine learning to help prevent overload as grids adapt to the strain of electric vehicles charging at home, and how considering or combining concepts from a lattice of mental models can result in better decision-making outcomes. As always, you can get all the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show, the URLs for Josh's GitHub and Twitter, as well as my own social media profiles at superdatascience.com/665. That's superdatascience.com/665. If you enjoyed this episode, I'd greatly appreciate it if you left a review on your favorite podcasting app or on the Super Data Science YouTube channel. And of course, subscribe if you haven't already. I also encourage you to let me know your thoughts on this episode directly by following me on LinkedIn or Twitter and then tagging me in a post about it. Your feedback is invaluable for helping us shape future episodes of the show. Thanks to my colleagues at Nebula for supporting me while I create content like this Super Data Science episode for you. And thanks, of course, to Ivana, Mario, Natalie, Serge, Sylvia, Zara, and Kirill on the Super Data Science team for producing another scrumptious episode for us today. For enabling that super team to create this free podcast for you, we are deeply grateful to our sponsors, whom I've hand-selected as partners because I expect their products to be genuinely of interest to you. Please consider supporting this free show by checking out our sponsors' links, which you can find in the show notes. And if you yourself are interested in sponsoring an episode, you can get the details on how by making your way to johnkrohn.com/podcast. And thanks, of course, to you for listening. It's because you listen that I'm here. Until next time, my friend, keep on rocking it out there, and I'm looking forward to enjoying another round of the Super Data Science Podcast with you very soon.